So we're going to talk about the angle between two vectors. In order to do that, we need a calculator, so please make sure you have one available. Make sure your calculator is also in degree mode. But for this, it's basically for when you have two vectors that you are looking at and analyzing, you have an angle that is always in between those two vectors. So when we're looking for the angle between two vectors, we're going to take and follow this formula here, which says that we take cosine of theta, and it equals the unit vector, or u, not unit vector, but u, dotted with v, divided by the magnitude of u times the magnitude of v. So we have the dot product divided by the magnitude of both vectors. And this formula will help us find the angle between any two vectors.
Attention, Mrs. Sass, if you're still...
Sorry for that. But this will help you find the angle between any two arbitrary vectors, any vectors that are out there. So we have cosine of theta is equal to the dot product between u and v divided by the magnitude of u times the magnitude of v. As a reminder, dot product formula is u1 times v1 plus u2 times v2, where I take x times x and I add it to y times y. So let's go ahead and look at an example. So the example that I have here is I have u is 4, 3 and v is 3, 5. So in order to do this, I'm always going to start with my dot product first, and I would just do this formula to find the angle between in stages. So what I mean by that is you're going to take u before you do anything else. So I'm going to take 4, multiply it by 3 from the other problem, and then I'm going to take 3 and multiply it by 5, the x times the x plus y times the y. So that is going to equal 27. So my dot product is 27, so now let's look at my magnitude. We're going to find the magnitude of both u and v, so we find the magnitude of u first. That is the square root of 4 squared plus 3 squared, which is equal to the square root of 25. Now the square root of 25 is 5, so I'm going to simplify it to 5, and we can leave it like that. Or you can leave it as a square root of 25. It really doesn't matter. And I'll show you an easier way to enter into the calculator, but you can just leave it 5 or the square root of 25. We're just going to use it in the next step, so all we really need is for that simplifying as there, like from here. It doesn't have to be too much more simplified than that. Then we're going to find the magnitude of v. So remember, the magnitude of v is the square root of 3 squared plus 5 squared, that's the x squared, and y squared of the vector v. And that's the square root of 34. Now I'm not going to simplify this, I'm going to use just that value. Try not to simplify square roots here because the square root is not our final answer. Our final answer is the angle. So now we're just going to plug everything into that formula above. So that means I'm taking cosine of theta, and I'm going to take my dot product, and I'm going to multiply it or divide it by the multiplication of my magnitudes. So that is 27 is my dot product over 5 times the square root of 34. Now when you enter this into a calculator, please make sure that you put parentheses around the square root here in the denominator. And when you're entering this, when you're trying to find the angle, as a reminder, it's cosine inverse of my angle. Sorry, got a little slow there. But it's cosine inverse of whatever this is. So that's 27 divided by, and then I would put those parentheses, 5 square root of 34, and then close those parentheses. So in my calculator, I should be in degree mode. Second cosine, so I have the cosine negative, then I do 27 divided by 5, and we're going to put in parentheses, open the parentheses, 5, and then second square root would be the second in the x squared button, and then you're going to have 34 entered. Now you're going to want to close parentheses multiple times. We're going to want to close the parentheses for the square root, close the parentheses for the 5, and close the parentheses that were around the 27. So it's like 3 close of parentheses, and then you hit enter. And my answer is 22.2. And that is my final answer for this problem. So that is the angle between those two vectors. No graphing necessary, just follow the formula and plug things in. Let's do another example. Okay, so for our next example, we're going to do the same thing. We're going to do the dot product, the magnitudes, and then we're going to enter them into the formula. So I'm going to kind of do this a little bit quicker because we all should know how to do dot product. We should all know how to take the magnitude. So if we take the dot product as a reminder, it's 2 times 1 plus -4 times -2. In this case, I get 2 plus 8, which is 10. So that is my dot product. And I have already gone ahead and completed the magnitude of u, which if you pause and do that real quick, you should get the square root of 20. And I've completed the magnitude of v. If you pause real quick and do that, you should get the square root of 5. Okay, so you can go ahead and do those on your own. But when I'm entering this into the calculator, that's what I really wanted to talk to you about. So I have 10, which is my dot product, divided by the square root of 20 times the square root of 5. Now, one way you can kind of eliminate having to do those parentheses around the denominator is by doing this. So leaving 10 alone, and then underneath the square root, so multiply these two numbers together because they're both in a square root. So that would be the square root of 100. And then I can enter it into the calculator. So I can take my angle, which is cosine inverse of, and then I could put 10 over that square root of 100. And I don't have to do any more simplifying than that. So second cosine 10 divided by the square root of 100. And in this case, my angle between is 0. If you had graphed this beforehand, you would have been able to tell. So there is some benefits to graphing, but if you had graphed, you would have been able to tell. I have negative or positive 2, negative 1, 2, 3, 4. This is my first vector, so it goes here. And then my second vector goes to 1 down 2. And notice that they are literally on the same line here. So there is technically no angle between. So sometimes graphing it does help, but you don't have to graph it to determine the angle between. But that is something that I would kind of suggest maybe doing. I don't know. One more example, and I know that I've told you before that you can skip examples if you're good, but watch this last example. Please, because there is something that we have to talk about that we haven't talked about yet. So give me 1 second. Okay, so for this example, I'm going to show you, just real quick, I'm going to go through it again. Now, I'm not going to go through the steps. Again, we're just going to show you really quick what these all give you. So the magnitude of u will give me the square root of 13. The magnitude of v is going to give me the square root of 52. You can go ahead and try this problem if you want to. And my dot product should give me 0. So those are all the things that I need. I know how to calculate them. So let's look at the formula for cosine. So the cosine formula says I take the dot product, which is 0, divided by the square root of 13 times the square root of 52. Now this doesn't really matter, okay? Because 0 over anything is okay. Remember, it's 0 in the denominator that's not okay. 0 in the numerator means that this is cosine of theta is equal to 0. Now when we take this in our calculator, I get cosine inverse of 0, and then I can enter that. So if you did that in your calculator, second cosine, and we put 0, enter, I have 90. And this is actually a very special case. Automatically, if your dot product is equal to 0, your angle between those vectors should automatically be 90 degrees. These are called orthogonal vectors. So if my dot product, this is something you need to write down and know, but if my dot product equals 0, then my vectors are orthogonal. You may be asking me, what does orthogonal mean? Well, orthogonal is another word for perpendicular. And that means that they have a 90-degree angle between them. So that's a way to kind of skip some work if you do the dot product first. And that's why I always say to my students, do dot product first, because if you get 0, then you're skipping a bunch of work. You don't actually have to go through the whole process of doing all of the work. That is it for this lesson. I hope this video helped, and I hope you're having a great day.